In the last video, we talked about the limit of a function at a point, okay? And then we found the limit of a function at a point by using graph, right? If you are finding a limit of a function, let's say fx, at the point A, what we did is we draw the graph and then we look at the height of the function close to A towards the left and check the height. And then you find out the height of the function close to A towards the right side and find the height. If the height on the left side and the right side are almost equal to a number L, then L is called the limit, okay? That's how we find out from the graph. And from the chart, what we did, we plug in the different points on the left side, and then we plug in the different points for x, different values of x towards the right side, and then you check the height or find the value of fx. And if they are equal to each other, then we say that L is the limit. Also, we did the epsilon delta definition of the limit, and epsilon delta definition is used basically to find out if you want to be within epsilon distance from L values, then how close should you go to the A values is the delta distance, right? And then sometimes you will be asked to find out delta. If you want to find out delta such that fx is within epsilon distance from L, then you start with absolute value of fx minus L less than delta, and then you simplify this, you plug in the value of fx, okay, and then plug in the value of L, plug in the value of epsilon, and then simplify this and then try to get x minus A less than delta. So and then whatever value you get here will be the delta value that you are interested to find out. That's what we did in the last video, okay? On this video, that is section 1.3, we find the limit analytically. What does that mean? Meaning that the way of finding the limit using the chart or the graph is not easy. It takes a long time, right? It has a lot of work. But we don't use this method to find out the limit in general. What we do is, if you are trying to find out the limit of this function, for example, what you do, you plug in that limit x equals to 3 here. And then it is basically similar to or same as finding the functional value, okay? So what we do, you plug in that 3 on here. So how do I find out this limit, for example, is you do 4 equals to 4 times x squared is 3 squared. I'm just plugging in x equals to 3 plus 3 times 3, right? And then plus 5. So how much is that? 4 times 3 squared is 3 squared is 9, right? So 3 squared is basically 9. So this is 9. 4 times 9 is 36. And this is 9. 36 plus 9 is 45 plus 5 is 50. So 50 is the answer there. You see that? Okay, so basically to find out the limit analytically, you just plug in the limit, plug in that x value into the x there. And whatever number you get, if this number is finite, like 0 or minus 5, 10, 20, 50, like that, a finite number, then that is the answer. Sometimes when you plug in the limit, plug in that number, you get infinity. In that case, we say the limit does not exist, okay? Or sometimes we get 0 over 0, okay? In that case, you will have to do some more work before you plug in the limit. All right, so I will give you that type of example later, but for now, just keep this in mind. If you are finding the limit of a function, you plug in that value into that x. You plug in that limit value into the x, okay? Let's do another example. Limit x tends to, let's say, negative 2, okay? X tends to negative 2, x squared over x minus 4. How do I find out this limit? Again, just plug in that negative 2 square over negative 2 minus 4. You see that? What is negative 2 square? That is positive 4, right? Because it is negative 2 times negative 2, right? So negative negative is positive, 2 times 2 is 4. That's what you get. So over negative 2 minus 4 is negative 6. Now we simplify that, divide by 2, what do you get? Equals to negative 2/3. I put that negative sign in the middle. You can put it in the denominator or numerator or in the middle, so it doesn't matter. Okay, so the limit of this function is negative 2/3. But graphically, what does that mean? That means if you are close to negative 2, then the height of the function will close to negative 2/3. That's what it means. That is below the x-axis because it is negative, right? All right, let us do this example. Let fx is 2x squared minus 3x plus 39 and gx is cube root of x plus 5. Now what you want to do is you want to find limit x tends to 4 fx. How do I do that? It is limit x tends to 4. Fx is just plug in that values, 2x squared minus 3x plus 39, right? Now you plug in 4 for x. So you will get 2 times 4 squared, right? Minus 3 times 4 plus 39. You see that? So how much is that? 2 times 4 squared is 16, right? So 16 times 2 is 32 minus 3 times 4 is 12, right? So 32 minus 12 is 20 plus 39 is 59. That's what you get. Here I just replace the value of fx. I just write the value of fx. Limit x tends to c. 2x squared minus 3x plus 39 over 12. Now you replace x by c. So 2 times c squared minus 3 times c plus 39 divided by 12. That's it. We cannot simplify further. And here there is a composite, right? G composition fx. You see that? So what you do, you just plug in the value of fx first, write the value of fx, limit x tends to 4. G is still there. I plugged in the value of fx is 2x squared minus 3x plus 39. Now what you do is you write the limit inside. You replace x by 4 there. G is still g, right? 2 times 4 squared minus 3 times the 4 plus 39. You see that? So how much is that? It is basically g. 2 times 4 squared minus 3 times 4 plus 39 is 59, right? 59. Now you replace x by 59 in the function g. You see that? That is the function g. So what you do is cube root of 59 plus 5. You see that? How much is 59 plus 5? 59 plus 5 is 64, right? And what is the cube root of 64? Cube root of 64 is basically cube root of 4 times 4 times 4, right? So since there is cube root and there is a product of 3 4s, so the answer is 4. So cube root of 64 is 4. You see that? So now the last one is there is 5 times gx squared, but there is limit. I should not forget the limit there. So let me write down limit x tends to 4. There is 5 times gx squared. Okay, so gx is how much? Cube root of x plus 5 and then square. So you can write the limit directly inside. So how much is 4 plus 5? So 4 plus 5 is 9, right? Cube root of 9 square. That is basically 5 times cube root of 9 and then square. You see that? So how much would that be? That is 5 times. Do you know how to write a cube root of 9 in the exponent form? I would write this way, okay? So this is 9 to the 1/3 and then square. You see that? Because whenever there is a cube root or square root, there is 1 in the exponent of 9, right? That number inside that angle, inside that root angle, goes in the denominator of the exponent. So 9 to the 1/3. Okay, how can you write that 9? Can you write 3 to the square? So it is like 5 times 3 to the square times there is 1/3, because 3 squared is 9, right? Times there is 2, because that square is 2. So ultimately you will be able to write this as 5 times 3 to the 4/3. That is the final answer. But be careful, you cannot multiply 5 and 3. Why? Because 3 has exponent 4/3, 5 has exponent 1. They have different exponents, so you cannot multiply. So the final answer is 5 times 3 to the 4/3. That is the final answer. And another example I want to take here is evaluate limit x tends to 5, x minus 5 over x squared minus 25. So let me plug in the limit directly. What you get is 5 minus 5 over 5 squared. You just replace x by 5, right? So 25 minus 25. So you get 0 over 0, right? So which is indeterminate form. We don't know how much is that. So we will learn about that later, okay? But we don't know what is that. So in this case, you do not plug in the limit directly because 0 over 0 is not a right answer. It cannot be an answer, okay? So what do you see? What you do for this is you simplify the top and bottom. So what I do is limit x tends to 5 and then the top is x minus 5 already in the lowest form. Now get the factor of x squared minus 25. You can write x minus 5 and then x plus 5. You see that? Now this is x minus 5 divide x minus 5 is 1. You can cancel that out. And what is left is limit x tends to 5, 1 over x plus 5 is left. Okay? So now the next step is to just plug in x equals to 5 there. 1 over 5 plus 5 is 1 over 10. Okay, so this is slightly different from the previous problem. What is the difference there is when you plug in the limit, you got 0 over 0 form. There is a rational function, meaning there is x in the numerator and x in the denominator. When I plugged in the limit at the beginning, I got 0 over 0, which is not the right answer. So what you do, you simplify, you factorize, you simplify, okay? You simplify and then you cancel the factor, one of the factor common, that is common to both top and bottom. And then what is left, you plug in the limit there, okay? That's what the rule is. To find out the limit x tends to a of x, plug in x equals to a. If it is finite, you are done. That's what we got in all these three examples, okay? And then if you get 0 over 0 form, that is the last example we did, simplify the numerator and denominator for denominator and get the lowest form. We simplify the numerator and denominator and we cancel out and then we got the lowest form. This is the lowest form, right? And then plug in the limit. If this limit is finite, then it is the limit, right? If it is not finite, then it is either infinity or limit does not exist. So for the infinity limit, we call infinite limit. We will discuss that later. For now, if it's infinite, we say limit does not exist for now, okay? But in the next section, we will see infinite limit, okay? But for now, if you get 0 over 0, you will have to simplify and then and get the lowest form. If the lowest form is of, after you plug in the limit in the lowest form, if it is finite, the limit exists. If it is infinite, then the limit does not exist, okay? The next rule is sometimes you get radicals, meaning the root in the numerator or in the denominator. Then in that case, you may have to use the conjugate multiplication. So next example is we will have to use conjugate multiplication where the numerator or the denominator has the root in it. Okay, look at this example that that is a limit. Find the limit x tends to 22, x plus 3 minus 5 divided by x minus 22. If you plug in this limit directly, what do you get? You get 22 plus 3 is root 25. That is 5 minus 5 is 0, right? You get 0 on the top. And 22 minus 22, 0 on the bottom. So this is not the right answer, right? So 0 over 0 cannot be the answer. What you do now, try to simplify and get the lowest form, but it is hard to get the factors on the top and bottom as in the previous example, right? What we do, since there is a root, as the last rule suggested, what you do is you multiply by the conjugate, right? So what you do here is write down that limit x tends to 22 root x plus 3 minus 5 divided by x minus 22, okay, times conjugate of the numerator or denominator. What we do here usually is if there is a root in the numerator, you multiply the conjugate of the numerator. If there is a root in the denominator, you multiply by the conjugate of the denominator, okay? That's what you do. So what you do here is root x plus 3 plus 5 over root x plus 3 plus 5, okay? Now you multiply the top, it is like a minus b times a plus b. You can FOIL it or you can use that formula, okay? You can FOIL it, that is perfectly fine. Or use the formula a minus b times a plus b is a square minus b square, right? Do you remember that formula? That formula is basically a plus b times a minus b. If you multiply that, you will get a square minus b square. That's the formula that I want to use here. So what you get there then, you get limit x tends to 22. It is like a minus b, a plus b, a square will be x plus 3 only, right? Because square of the square root will be just square and square root will cancel out. Minus 5 square is 25. Divide by, let me keep that, x minus 22. I don't want to FOIL the denominator. I just keep it for some time. Root under x plus 3 plus 5. Okay, so what do you get in the top? If you simplify, you will get, this is basically x plus 3 minus 25, right? Basically x minus 22. So limit x tends to 22, x minus 22 on the top, and then you got x minus 22 on the bottom, and then there is one more factor on the bottom, x plus 3 and then plus 5. You cancel that out, divide by x minus 22. So you got 1 over, so let me write down limit x tends to 22, 1 over x plus 3 plus 5. Now you plug in that x tends to 22. After you plug in, you don't have to write the limit, okay? So what you get is 1 over root under 22 plus 3 plus 5. You see that? So 1 over 22 plus 3 is 25. So root 25 is 5, right? So 1 over 5 plus 5. So your final answer is 1 over 10. You see that? So sometimes you may have to conjugate by the conjugate of the numerator, or sometimes if it wasn't the denominator, you would do conjugate of the denominator. So that is another way of simplifying the rational function, okay, by multiplication of the conjugate. So that will cancel that term that creates 0 by 0. Okay, so let me take one more example. So that example I want to do is example. So what I want to do is find limit delta x tends to 0. Instead of x, we have delta x here, but it is not a problem at all. Okay, f of x plus delta x minus fx over delta x for fx equals to 6x squared minus 4x. For this function, I want to find out f of x plus delta x minus fx over delta x. How do I do that? Let me do this problem. So solution is limit delta x tends to 0. You want to find out f of x plus delta x minus fx over delta x. That's what you want to find out, right? So what is the value of f of x plus delta x? Let me write limit delta x tends to 0. What is the value of f of x plus delta x? You just replace x by x plus delta x, right? What you get is 6x plus delta x square minus 4x plus delta x. This is the value of f of x plus delta x, because f of x is that, right? You replace x by x plus delta x minus, what is fx? That thing, right? You do 6x square minus 4x divide by delta x. Now let me continue right here, equals to limit delta x tends to 0. Now you simplify that. You get 6 x plus delta x square is x plus delta x times x plus delta x, right? X plus delta x times x plus delta x minus, you distribute that 4x plus 4 delta x, 4x plus minus 4 delta x. You see that? Because you need to distribute that, you distribute that negative 4. Okay, so minus 4 delta x minus 4 delta x, and then you distribute that negative sign as well. negative 6x square, and that will be plus 4x divide by delta x. You see that? Now what you do is, you see that negative 4x and positive 4x cancel out, negative 4x and positive 4x. Now these terms will not cancel out, they will still be there. Now you need to FOIL that x, you keep 6 and you FOIL that. What do you get? You get limit delta x tends to 0, 6. So this will be x times x is x square plus x times delta x delta x plus x times delta x again, x delta x plus delta x square. You see that? And then what is left is negative 4 delta x minus 6x square divide by delta x. Now you simplify the top, you will get limit delta x tends to 0, 6 x square. I'm distributing this 6. Now what is that? This term is x delta x, this term is another x delta x. So if you add, you will get 2x delta x, right? But if you multiply by 6, you will get plus 12x delta x. You see that? Plus delta x square minus 4 delta x minus 6x square. Now you cancel that negative 6x square and positive 6x square. What is left is 12x delta x plus delta x square minus 4 delta x. And then there is delta x in the denominator. If you plug in the limit right here, you will get 0 over 0. Okay, if you plug in the limit, for example, you will get 6, this will be 0, right? Delta x square will be 0. So 6x square minus 4x and then minus 6x square minus 4x. That will be 0 over 0 when you plug in the delta x tends to 0. Now, what is left here is 12x delta x plus delta x square minus 4 delta x. Now, let's take delta x out. Limit delta x tends to 0. I want to take delta x out. What is left is 12x plus delta x minus 4 divided by delta x. You cancel that delta x and delta x, and when you take the delta x tends to 0, that will be 0 as well. So what is left is 12x minus 4. You don't need to write the limit because you plug in that delta x tends to 0 here. So 12x minus 4 is the final answer for this. Okay, so if you have this type of problem where you don't get scared, so don't get scared with this. Just plug in the value of f of x plus delta x. That replace x by x plus delta x and then minus fx. Just plug in fx divided by delta x and then you simplify. And then when you plug in the limit right here, you will get 0 over 0. But you simplify and then cancel the terms that can be cancelled and can take the delta x out and cancel that delta x out, the factor out delta x and then delta x in the denominator, and then plug in the limit. And then you don't get 0 over 0. So that will be the final answer. Okay, guys? Okay, so the next thing we want to do is we want to talk about the trigonometric limits, meaning that all the limit problems we did so far, they have just x, okay? We didn't have sine x, cosine x like that. But if there is a limit that has sine x or cosine x or tangent x, cotangent x like that, how do we find out the limit of that type of function? That is the next problem I want to do. To find out the trigonometric limits, we need two formula. Okay, so these two formula, actually there is a derivation to, there is a way to find out this formula to prove this formula. Okay, there is a geometrical way to prove this formula, and for the second formula we use the first formula to prove the second formula. Okay, but I'm skipping that for now, and let me tell you what these formula are. Limit x tends to 0, sine x over x is always 1. So make sure that this value match with that value to get that, to use this formula, okay? And similarly, limit x tends to 0, 1 minus cosine x over x is equals to 0. Again, this must match with that. By the way, these three must match, okay? So this and that must match. And similarly here, this and that must match. But for the limit, it is not a big problem because you can always get any limit you want from x. For example, if there is 5x and 5x, you can multiply both sides by 5 and then do 5x tends to 0. But we mainly focus on these two values, okay? If they match, then you can use that formula. sine x over x, the limit x tends to 0 is 1, and 1 minus cosine x over x, limit x tends to 0 is 0. Okay, let us do these examples. So limit x tends to 0, sine x over sine 3x. You see that? So here the first formula has sine. To use this formula, you need to have sine x over x only. But there is 3. But what you can do there is, you can do 1 over 3, and then do limit x tends to 0, and then sine x over x, right? What I did is I pulled that 3 outside. So you cannot pull x outside because this x has the limit x tends to 0, okay? But if there is a constant in the denominator that is not attached to any sine or cosine or anything, then you can pull that out. So what is that value is basically, this is from the formula, this is 1. So it is 1/3 times the 1, that is 1/3. You see that? So here there was 3 times x in the denominator, so I pull that outside the limit. Let us look at this example. Here there is sine 3x over x. Can we use the same technique? The answer is no. Why? Because you can pull this 3 from the sine. Why? Because that is sine, and then inside the angle there is 3x. You cannot pull that out. But what we can do there is limit x tends to 0, and then what you can do is sine 3x over x times 3 over 3, right? This is basically 1. I'm multiplying by 1. It doesn't change anything, so we can write equal. But what we are doing this is, since there is 3x, I need 3x in the denominator, okay? So what I want to do next is I want to move that 3. And then this 3, I can pull that outside. 3 limit x tends to 0, and then I will do sine 3x over 3x. You see that? And if you want to, you can multiply 3. You can multiply both sides of this limit by 3 as well, because 3x goes to 3 times 0. That is basically 0. But it is just straightforward. So you don't have to do anything on the limit here. So what you can do here is limit x tends to 0, sine 3x over 3x. You see the first formula? You have the same quantity on the sine angle and the bottom. So this quantity is basically the 1. Okay? This quantity is basically 1. So the final answer is 3 times 1. So this is 3. How about this one? This example. So here you have limit x tends to 0. We have sine 3x. Okay? On the denominator we have 2x. But what we need 3x, right? So let us write down what you need. Similar to the previous example, what I did here is, there was 2x, but I want to pull that 2 out. Okay, I pull that 2 outside here, outside before the limit. Okay, and then what is left is just x, and then if I multiply and divide by 3, so it will be 3 divided 3, right? 3 divided 3, and then you move that 3 to there, and then there is nothing left, right? So what you get there then equals to 1/2 limit x tends to 0, and then sine 3x over 3x. You see that? So I moved that 3 to the with x. So sine 3x over 3x. Now this 3, you can move that to the front as well. So I move that to the front as well. You see that? Now what is the answer then? So this is basically 1, right? Because sine x over x. If there is sine something, then, and if there is the same thing in the denominator, then the limit is always 1. So 3/2 times 1 is just 3/2. How do you do this one then? That 3/2 is the last answer, final answer. How about this one? There is sine 3x, there is 2 sines. So we'll use that formula twice. How do I do that? This is what I want to do. I want to write the limit x tends to 0, and then what I'm trying to do is sine 3x over 3x times 3x. Similarly, sine 7x over 7x times 7x. Why did I do that? There was just sine 3x. I multiplied and divided by 3x. If you cancel out, you will get just sine 3x. But I multiply and divide. Why did I do that? Because there is 3x, I need the 3x to use this formula number 1, right? Similarly, in the denominator, there is 7x. I need the 7x in the denominator. And there is, I multiply by 7x to balance that. Okay? If you cancel that, you will get just sine 7x. Okay? So you cancel that x and x. What is left is this value will be 1, right? When you take x tends to 0, this value will be 1. So what is left is 3 over 7, just 3 over 7. Now next example. This 3/7 is the final answer. Next example is similar. To use the 1 minus cosine x formula, you need the same angle, the same thing as in angle in the denominator. So what I need in the denominator is 3x, but I need to multiply by 3x to balance that, right? So limit x tends to 0, I can do 1 minus cosine 3x over 3x times 3x divide by sine 5x over 5x times the 5x. You see that? Because to use the first formula, you need 5x in the denominator of sine 5x, and for the 1 minus cosine 3x, we need 3x. But you cannot just divide by 3x. You need to cancel that. We need some term to balance that. So I multiplied by 3x. If you cancel, you will get just 1 minus 3x. Similarly, if you cancel 5x, you will get just sine 5x. Okay. Now here, x divided by x is 1. Okay. So this value is 0. You see that? This value is 1, right? So basically what is happening is this value is 0, this value is 1. So what you get is 3/0 is 0 over 1. So that the final answer is 0 there. You understand? Okay, so next thing I want to do is this example, tangent 5x. Since our formula doesn't have tangent, just sine and cosine, you try to change that tangent into sine and cosine. So what I'm doing is limit x tends to 0, sine 5x over cosine 5x times 2x, right? That's what you do. So what we can do next is I will do limit x tends to 0. I need sine 5x over 5x times 5x, because to use the sine formula you need the same 5x in the denominator, right? And in the denominator of that it is cosine 5x times the 2x. Let's cancel that. X and x, 5x divided 2x is just 5/2, and you use the limit. Sine 5x over 5x is 1, okay? And cosine 5 times 0 is basically, this is what you do. This value is 1. This value is basically 1, okay? Now what you do next is I am plugging in the limit there. 5/2 is there. That's the number 5/2 because I cancel x and x. And you plug in the limit times 1 over cosine 5 times 0. Look at that. When I plug in the limit, I no more write that limit value there, lim thing, because I plugged in that already. So cosine 0, 5 times 0 is 0 degree, right? So cosine 0 is 1, so the answer is 5/2. And the final example I want to do is there is sine x, 1 minus cosine x, both of the numerator are there, but you can divide that x square into x and x. So you can do limit x tends to 0, sine x over x times limit, you can distribute the limit, no problem. The limit can be distributed anywhere in the plus, minus, product, quotient, root, anywhere, okay? X tends to 0, 1 minus cosine of x over x. So this value is 1. This value is 1. This value is 0, right? So 1 times 0 is 0. Okay? So this is how we find the trigonometric limits. Thank you, guys.